Okay, the first thing whenever you're looking just to find the limit is you see if you can plug your number in. If you plug in 4, it's no good. If you plug in 4, you get 4 minus 4 is 0, and we can't have zeros in the denominator. So if it's something with x squared, you're probably going to factor it. And you just got to remember, you've done this before, 2 sets of parentheses. First value here is if it's just x squared, there's going to be x and x, because x times x is x squared. You find the factors of this number. What goes here and here has to be the factors of this number. So we could put 4 and 1 or 2 and 2. So which pair of these numbers can I get a 5 out of? Well, I can't get a 5 out of 2 and 2 when I add them or subtract them. So it's got to be 4 and 1. And I need to get a negative here and a positive here. So the only way that can happen is if this is a negative and this is a negative. So that's x times x is x squared. X times negative 4 is negative 4x. Negative 1 times x is negative 1x. Those two together make my negative 5x. And negative 1 times negative 4 is positive 4. So it works. So now you got this. So now these two guys cancel. So all you have is this. The limit as x approaches 4 of x minus 1. Now you can plug in 4. 4 minus 1 is 3. So that is the limit right there. On the graph, it looks like this. Somewhere. No. Yeah, it's this one. This is what the graph would look like of that. If you put it in the calculator, it would look like this. The error occurs at 4. If you look at the table, you'll see an error, but as you go towards 4, this gets very, very close to 3 from both sides. And so that's what it looks like in the calculator. I noticed that you had done something like that, but it would be, let's see, we got x squared minus 5x plus 4, and then x minus 4. So here's the graph, just a straight line, at least it appears to be, but there's really a gap at 4 if we look at the table. The table, get down there here, right there at 4. So it approaches 3 from both sides, and so that's what you get when you do this. Number 11 is the limit as x approaches 7 of x squared plus 6x plus 5 all over x minus 7. Again, you could graph this. I mean, you could, of course, you can always graph it, but this top thing factors, and it's always good to get good at factoring. This is going to be x plus something, x plus something, because these are both positive. 5 only has 2 factors, 5 and 1, and it works. X times x is x squared. X times 1 is 1x. 5 times x is 5x. That's where the 6x comes from, and 5 times 1 is 5. So you factor it. X plus 1 all over x minus 7. Well, nothing cancels out. You still can't plug in 7. This one, this doesn't help, so this really does not exist. And on the graph, I graphed it, and it looks something like this. It looks this weird thing, and I had to zoom way out. This is way zoomed out. But see how it goes in opposite directions? One of them shoots this way, and one of them shoots this way. You have to approach the same number. This is a dead giveaway that it does not exist. And the last one is number 12. The limit as x approaches 16. 4 plus square root x. 16 minus x. Again, can't plug in. You get 0 in the denominator. Can't have zeros in the denominators. That doesn't mean it won't work. This is where you rationalize. So you're going to multiply by what's called the conjugate of this. You just reverse it, 4 minus square root x. And then on the top, this is what you're doing. You're multiplying 4 plus square root of x times 4 minus square root of x. Well, this is useful because the first two is easy. 4 times 4 is 16. What's going to happen is when you multiply 4 times this one, you get that. So this move right here, that's what you get. This one right here, you get this. Well, those cancel each other out. So those are gone. The only thing that's left is this times this. Well, the square root of x, positive square root of x times negative square root of x is just negative square root of x squared, which is x. Right? Square root of x squared is x, so you get this. So in the numerator, this times this, you get 16 minus x. If you look at the denominator, you don't have to multiply this out, just leave it. If you plug in, we're still looking at the limit as x approaches 16. I mean, you're still going to get a 0 down here. You get 0 here, you get 0 here. It still doesn't work, so this one does not exist either. And I graphed it as well, and that's what it looks like. Again, you have to zoom way out, I think a little bit, I don't remember, but you've got this asymptote, but one of them goes off to positive infinity, the one of them shoots down to negative infinity. This is, again, a dead giveaway on the graph that this limit does not exist.